Alright guys, in this video we're going to talk about how to draw Lewis structures. Now, Lewis structures are really helpful as it kind of gives us a good idea exactly. It gives us basically a molecular representation that shows the connection between the nonmetals and the location of the lone pair valence electrons. Okay, and so let's just kind of draw a couple of few Lewis structures. So this is like the Lewis structure of water. This is the Lewis structure of ammonium. This is the Lewis structure of methane. All right, and so it just kind of gives us a really good idea exactly what is the overall structure, and then it tells us a lot. You know, there's a lot of chemistry or a lot of conclusions that could come out just from drawing the Lewis structures for molecules. All right. So, I guess the question is, how do we draw Lewis structures? You know, what's the thought process? What's the step process? And that's what I'm going to go ahead and show for you in this video. So your very first step is that you want to determine the total number of valence electrons of all the atoms in the molecule or the ion. So anything that's covalent compounds, and polyatomic ions are covalent compounds, okay? Or they're bonded covalently anyways. So we want to figure out how many valence electrons we have. All right, so I have these 4 examples here, and we're just going to work through all 4 of them for practice sakes. All right, so we have this first one, we have carbon. And now what you need to do is look at the periodic table, okay? And depending on the placement of the element, you could kind of figure out how many valence electrons we have. So let's quickly review this. So for example, we have this first example where we have carbon, right? CH4, methane. All right, so you want to first look for carbon. Now we see here's our periodic table. All right, and then depending on what column or what group it's in, could kind of give us a good idea how many valence electrons it has. So like for example, this group right here has 1 valence electron. This group right here has 2, 3, 4, 5, 6, 7, and 8. All right. So if you find carbon, so we see here, so carbon is right here. All right. And we could clearly see that carbon has 4 valence electrons. Okay, and so that's what I'm going to write here off to the side, that carbon has 4 valence electrons. And then I want to see how many valence electrons hydrogen has. Well, let's look into our periodic table here. So we see hydrogen is in that first group, so hydrogen in and of itself has 1 valence electron. So we have 1 valence electron for hydrogen, but if you also notice that we have 4 hydrogens in this compound. All right, so I'm going to multiply this number by 4, and we're going to figure out what's the sum. So 4 plus 1 times 4, well, we have 8 total valence electrons for this compound of methane. Let's look at the next example. So we have ammonium here, the ammonium ion, right? NH4 plus. So this one's just a little bit different, but we'll talk about this. So we first have to figure out how many valence electron nitrogen has. So let's go ahead and look at this periodic table, and we see that nitrogen has 5 valence electrons. All right, so I'm gonna put my periodic table off the side here, and so my nitrogen has 5 valence electron. Hydrogen, all right, just like we stated from the last problem, hydrogen has 1 valence electrons, okay, but you've also noticed that I have 4 of them, so I'm going to multiply this number by 4. Now, one more thing you have to consider is that we have a charge, okay? What does the charge mean? Well, the charge tells us that there's an unequal number of electrons compared to protons, right? If it's a neutral, you have the same number of protons, you have electrons. But in this case, we have 1 more proton than we have electrons. So this one, it lost an electron. It's missing an electron. So I need to take account of that when I'm counting my valence electrons. And so since this is a +1, that means we have to subtract an electron because it's positively charged. All right, so I'm a -1 electron here. And I'm going to add this up. So 5 plus 1 times 4. 1 times 4 is 4, so 5 plus 4 is 9, but subtract 1, so I have 8 valence electrons in this case. All right, let's look at the next example. So the next example, I have the sulfite ion, SO3 2 negative. All right, so first look for sulfite. So sulfite is here. All right, so I'm gonna highlight it. We see that sulfur, is here, and we can see that it has 6 valence electrons. So I'm gonna put the periodic table away. All right. Oh, this thing moved. All right, well, we'll fix that. Just like we said earlier, this is -1, so this 8 valence electrons. Okay, so sulfur has 6 valence electrons. All right, let's look at for oxygen. All right, so let's go back to our periodic table here. Oxygen is in that same group as sulfur, so it also has 6 valence electrons as well. So I'm gonna put this to the side. So my oxygen, there's 6 valence electrons, and if you notice, there are 3 oxygens. All right, so 6 times 3 gives us, there's 18 in total, right? And then if you also notice is that we have a -2 charge. What does the -2 charge tell us? Well, that means that there are 2 more electrons in this overall compound. And so we need to add to our valence electrons count. All right, so 6 valence electrons from sulfur, 18 from our 3 oxygens. So 6 plus 18, that gives us 24. You add the 2 more, and so now we have a total of 26 valence electrons, and for this case here. All right, now let's look at the last one. All right, so the last one, we have nitrogen and oxygen. All right, so it's we kind of figured out the valence electrons for nitrogen and oxygen from the previous problem. So we know nitrogen has 5 valence electrons. There's only one of them. Oxygen has 6, but there's 3 in this case. All right, so that gives us 18. And then we see here, we also have a negative charge. So we're going to take account of this negative charge. So we're going to add 1 more electron. So 5 plus 18 gives us 23 plus 1. So we have 24 valence electrons in this case here. All right, so as I stated, step 1, the first thing you want to do is you want to add up the total number of valence electrons of all the atoms that make up the compounds. All right, so step 2, you're going to draw the structural structure. Now, what do I mean by a structural structure? Well, the structural formula, not structural structure, but structural formula. All right, so it's basically almost like a simplified Lewis structure where typically you just kind of draw the lines between each of the elements and showing how they are connected to one another. Oftentimes, structural formulas do not have lone pairs drawn or around the atoms. So, but anyways, how do we draw the structural formula? Not structural formula, but structural formula. All right, so to do that, you want to, well, pretty much most times the first element that's listed, it will be our center atom. It will be the atom that we put in the center, the central part of the whole formula, of the whole structure, really. And while all the other atoms are connected to the center atom by drawing a single line. All right, so what do I mean by this? All right, so let's look at our first example here where we have CH4. So CH4, this first atom that we see here is our C. So that's going to be our that'll be our central atom. So C will be my central atom, and then I'm going to have my H's, 4 H's off to the side, and each of them are going to be connected to the carbon by a single line. Okay, what does the line represent? Well, these lines represent 2 shared electrons. All right, so a line represents a pair of shared electrons. So that's how you draw your structural formula. So you just want to put the central atom in the middle, and then you put all the atoms outside. You just want to connect them to the center atom. So that's the one for CH4. Okay, and let's work through all the other ones. So we have NH4 here. Our nitrogen is our center atom. So I'll write a nitrogen here. Our hydrogen is our outside atoms. So I'm gonna write 4 hydrogens, and I'm going to connect them by a single bond. We call them single bonds, okay? Single bonds represent these two electrons. Same thing for the sulfur and oxygen here. So I have one sulfur, and then there's 3 oxygens around it. The orientation of the oxygens doesn't really matter here. Just the fact that you just need to make sure you have the correct number of oxygens. And then I'll draw my lines connecting from oxygen to the sulfur. So we're not done yet, all right? But this is our second step, right? And then next, also same thing for our NO3. So I started with nitrogen. I have 3 oxygens. All right, so I'm just kind of drawing this a different orientation. So just kind of show you that with Lewis structures, it doesn't kind of really matter about the orientations of the outside atom to the center atom, as long as you have the correct number. But here we have the NO3, the nitrate ion, and so this will be the structural formula for the nitrate ion, okay? Now, overall, I want to just kind of show it, or tell you this, when you draw the Lewis structure needs to have, or needs to portray, the same number of valence electrons that you counted in the very beginning. All right. And so, like, for example, methane at the very end, by the time I'm done, it's going to show 8 valence electrons. The ammonium, it's going to show, ammonium here is going to show 8 valence electrons by the time I'm done. The sulfite ion is going to show the 26 valence electrons by the time I'm done. The nitrate ion is going to show 24 valence electrons by the time we're done. All right. So, though, the whole point of structure, I mean, not to only just, give us an idea how it possibly may look like, but also what tells us, it should tell you how many valence electrons does the whole molecule, the whole ion contain. All right. All right. So step 3. All right. What you're going to do, you're going to add 3 lone pairs of electrons to all the outer atoms so that each atom connected to the central atom gets an octet. So it has a full octet. Remember, the whole point of this, of bonding, is for each atom to have a full valence shell. All right, whether it has taken electrons or is sharing electrons, but they need to have a full octet. Now, the only exception, well, there's a couple exceptions, but one of the exceptions is for hydrogen. Hydrogen, you never add lone pairs to it because hydrogen, it only needs 2 electrons to have a full valence shell. Okay, so let's kind of look at our examples here from earlier, and so that we could see exactly what we're talking about. So let's look at our first example here. So as I said, you want to add 3 lone pairs of electrons to all the outside atoms, except for hydrogen. So when we look at the first example here for methane, we don't want to do that, all right? Because if you notice, all our outer atoms here are all hydrogens. So we're not adding anything to this. All right, so let's move on to our next example. Here we have the ammonium ion. All right. And then once again, all the outer atoms that we see here are all hydrogens. So you don't want to add any lone pairs to them. So we'll leave that alone. All right, let's move on to the next one. All right. So we have SO3. So now we have oxygen. So we could add lone pairs of electrons in this case here. So let's go ahead and add the 3 lone pairs to each atom. So for oxygen, 3 lone pairs, 1, 2, and here's the 3rd pair. I'm going to do the same thing for these other oxygen, and I'm going to do the same thing for the last oxygen. All right. So what does that do? What's happening here? And so, as I said, when you add the 3 lone pairs, you are allowing the outer atoms to gain its octet, to have a full valence shell. Now, full valence shell, it consists of 8 electrons. Now, when we're looking at each of these oxygens, we can see that it has access to 8 electrons. What do I mean by that? So let's look. All right. And if you notice, if you notice, you have 1, 2, 3, 4, 5, 6, and then it's sharing 2 electrons with the sulfur. So this oxygen here has access to 8 electrons. Okay. And that's true for all the other oxygens, because if you notice, they're all set up practically the same way. Now for the last one, same idea that our nitrate ion. All right, so our oxygens need 3 pairs, 3 lone pairs. And so I'm going to go ahead and put in my 3 lone pairs. Okay. All right, so now we're ready for the next step. All right, so step 4. All right, so it states that you're going to calculate the number of valence, a number of electrons currently shown in the structure. At this point, we're going to calculate, figure out how many electrons do we see in our structure. And then you're going to subtract that number from the total number of valence electrons you calculate back in step 1. And then if and only if you have any remaining electrons left, then you will add those electrons to the central atom. All right, so let's go ahead and tackle that and see exactly what we are talking about in this case here. All right, so let's look at this first one. All right, so in this first example, we're going to calculate how many electrons we see in this picture. All right, now, if you recall, these bonds represent 2 electrons. So I have 2, 4, 6, 8. So currently in my picture, I have 8 valence electrons. Well, if you recall, we calculated from step 1, 8 valence electrons. So 8 minus 8, 0 valence electrons. So I got nothing else to give to the central atom. Okay, so let's move on to the next example. All right, let's count up how many electrons we see here. So remember, these bonds represent 2 electrons. So 2, 4, 6, 8. So here I am showing 8 electrons. All right, remember from the very beginning, we calculated 8 valence electrons. So if we subtract the 2, we have a total of 0 valence electrons. So I got nothing to put on the nitrogen part of this ion. Okay, let's move on to our sulfate ion. All right, so for our sulfate, let's go ahead and calculate what we have. All right, so we have 2, 4, 6. So I counted the bonds first. Now I'm going to count up each of the other electrons as drawn here. So I have 8, 10, 12, 14, 16, 18, 20, 22, 24. So I have 24 electrons here. All right, so 24 valence electrons are shown in my picture. If recalled, we calculated that this should be 26. So I'm going to subtract the 2. So 26 valence electrons minus 24 valence electrons, I have 2 valence electrons left. And so because I have 2 valence electrons left, I'm going to take these 2 and I'm going to draw it into my central atom here. Actually, my central atom here. All right, and so when I draw it, I'm going to have my 2 dots on the sulfur atom. Okay. Now, let's look at the last example with the nitrate. So nitrate, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so here I have counted 24 valence electrons. How many electrons did I started out with? I started out with 24 valence electrons. All right, so when I subtract the 2, I have 0 valence electrons. So I got nothing to give to the nitrogen here in the central atom. All right, and so that's the step. Okay, so let's move on to the next step. Okay, step 5. If the central atom does have a full octet, so if you have enough electrons to fulfill its full octet, then you are done. All right, so you complete the you complete the Lewis structure. All right, but if not, if it does not have a full octet, then we have to move on to the next step, and then we'll talk about the next step a little bit later. But let's go ahead and just identify if we're done or not. Okay, so let's look at the first one. We have methane. So let's look at carbon. We got to look at the central atom and see, does it have access to 8 valence electrons? All right, so carbon, we have 2 here, 2 here, 2 here, 2 here. So 2, 4, 6, 8. It has access to 8 valence electrons. So methane is done. This is the correct Lewis structure for CH4. Cool. Let's move on. All right, NH4. Does nitrogen have access to 8 valence electrons? Well, let's go ahead and figure this out. Well, we have 2 here, so it's sharing it, so we have access to those 2. We have 2 here, so that's 4, 6, 8. Yes, so nitrogen has access to 8 valence electrons. So NH4, this is done. This is the correct Lewis structure to the ammonium ion. All right. And typically, because to show that is an ion, what we typically do after this, and I'm going to kind of draw off to the side here, we will write N, H, 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 H. We put in as a bracket, and then we put the charge on the top. So to show that this is a polyatomic ion, that this compound in of itself has a charge. Okay. All right, but I just didn't want to draw the bracket there. It was just there's too many things going on here. All right, so that's that. Now let's move on to the next one. So for this one, for the sulfate ion, all right, does the sulfur have access to at least 8 electrons? Well, let's check it out. Well, we have, oops, need the highlighter. So we have 2 here, 4, 6, and then we got this lone pair, 8. So yes, sulfur has access to 8 valence electrons. So this one is done. All right. Once again, because it's an ion, the way we will really write this out is S. Don't forget the lone pairs. And then we got the lone pairs of sulfur in the bracket, and then we state its charge. So that's the sulfate ion. So this one's done. All right, now let's look at the last one, the nitrate ion. Does it have a full valence shell? All right, well, let's go ahead and check this one out. All right, so we see here we have 2, 4, 6. So no, nitrogen has not fulfilled this octet. And so it hasn't fulfilled this octet. So now we have to move on to step 6. Okay. And step 6 is not something that you always will do. It's one that's the last case scenario. If anything else, most times you will always go through steps 1 through 5. And then step 6 is always where, all right, when we're looking at the central atom, we gave all the electrons that we've calculated from step 1. All right. And we notice that the central atom still does not have doesn't have access to 8 electrons. So what do we do next? What is the last step? All right, so let's talk about this last step. So you basically, what you're going to do for step 6, you're going to take a lone pair from an outer atom, and with that lone pair, you're going to create a multiple bond with the central atom. All right, so let's kind of talk about what I mean by that. So here's our example, going back to nitrate. All right, so it's because the nitrogen does not have access to 8 electrons. It still needs, in this case, it needs 2 more electrons. All right, so what we're going to do, we're going to take a lone pair from one of the oxygens, and we could just choose any of the oxygens. Any of these oxygens are a good candidate. I'm going to use the one on top, okay? So I'm going to take a lone pair from it. So here's me taking a lone pair. All right, and I'm just kind of erase this so that way you could see it better. So now by taking the lone pair, what I will do now is I will create another bond between the oxygen and nitrogen. And so here's the first bond that we made. Now I'm going to make a second one. So essentially what happens is that you have this set of electrons. Now it will go and be shared between the nitrogen and oxygen. All right, so by doing that, you will see that now nitrogen has access to 8 valence electrons. All right, so the 2 here, 4, 6, 8. Now, you may ask, well, what about oxygen? You took away 2 electrons from oxygen. Not really. Now oxygen is really just sharing 2 because it still has access to 8 electrons. All right, if you were to count up the oxygens here, it still has access to 8 electrons. You have 2, 4, 6, 8. So in this case, everybody's happy, right? So this is the correct Lewis structure for the nitrate ion. And once again, because it's an ion, you need to put it in brackets. And so I will show you exactly how that really looks like. So we have our nitrogen here. All right, so here's that, and it's double bonds. All right, I know I'm kind of drawing this out of order, but I'm just want to make sure that I show the charge here. So this is the way how you would draw the Lewis structure of the nitrate ion. All right, so those are the 6 steps of drawing Lewis structures. All right, so remember step number 1, you want to determine the number of total valence electrons for the atomic for each atoms in that molecule or compound. 2, you want to draw your structural formula. 3, you want to add 3 lone pairs to each of your outside atoms as long as they're not hydrogen. 4, you want to calculate how many electrons you have in your picture in your structural formula, and then subtract that number from the total number of valence electrons that you calculate from the beginning. And then the difference of the two is how many electrons are left that you place onto the central atom. All right. Step 5, you want to make sure the central atom actually has an octet, has a full octet. If it has a full octet, then you're done. But if not, then step 6, you will make multiple bonds between an adjacent atom and the center atom. Okay, so this is how you draw Lewis structures.